Hey everyone, Mr. Kim Singh here, and now that we've kind of gained all these skills relating to data, we're going to look at analyzing these data sets. Now, in your textbooks, when we look at data sets, they often contain less than 10 data points. But in reality, if you think about it, where are we getting data these days? We're getting it from our phone, social media, all these different places, and it's not just going to be limited to 10 points of data. It's going to be not just thousands either. It's going to be like millions or billions or even more points that we're collecting, because we can collect this data at any point in time, right? And so we're going to need a lot more than a handheld calculator to actually calculate these things, right? And that's where our software comes in. So things like Excel, R, Tableau, SQL, some of these are actually languages. And in the Mathematics Advanced, we're going to get a little taste of what this is going to be like. But if you are interested, all you have to do is a quick little search for, like data scientist or something related to that. I spelled scientist wrong. That's don't tell the English teachers. And it comes with all these different results of what data science actually is. So please check that out if you're interested. Right. But let's have a look at some questions. So these are what I call reasoning questions. So here's a first example. We've got a small business and 7 employees that earn the following each week. And we want to work out if 970 is an outlier or not. So remember, for an outlier, you have to apply some certain conditions. It's not enough to just say, oh, it looks pretty far out, particularly because it's 3 marks over here, right? So the way that we do this is, remember, the conditions for the outlier are either it's less than, this is part 1, it's less than Q1 minus 1.5 times the interquartile range, or it's greater than Q3 plus 1.5 times the interquartile range. Okay, so these are the 2 conditions that we impose and that we are looking for. So both of these have the interquartile range, so I'm going to go ahead and calculate that. So remember, the interquartile range is Q3 minus Q1. And in this case, I've got 1, 2, 3, 4, 5, 6, 7 points of data. This here is my median, Q2. And so Q1 and Q3, that's going to be these 2 points here. So Q1 is 490 because that splits up the second half into 2 equal parts. So that's my Q1. And this is my Q3. Splits up my second half, right? Okay, so Q3 minus Q1, so I've got 680 minus 490. And that looks like it's going to be like 190. Okay, so I've done all of that. I've got my interquartile range. Now I need to check the conditions. So Q1 and Q3, they were 680 and 490. So check Q3 plus 1.5 times IQR. So that'd be 680 plus 1.5 times 190. I do kind of want to bring up my calculator just to check this one, because I always make mistakes when I try and do stuff mentally. 680 plus 1.5 times 190, so 965. And let's check the below one as well. So that's going to be 490 minus 1.5 times 190. Okay, and we get 385. So I'm looking for, okay, are there values which are less than this or bigger than this? Yeah, I just realized I made a mistake here. That should be a 1.5 there, not 0.5. So 195 is actually what that's meant to be. Sorry about that. Let's fix that up. Okay, so 195. I guess the question is actually only asking for 970 anyway, so I only need to check the the greater than condition, and it is 970 is larger than 965. So I'll just have a concluding statement. 970 is greater than Q3 plus 1.5 times the IQR. 970 is greater than 965. Therefore, it is an outlier. Okay, so make sure you have to make sure you justify your answer as well with the calculations. That's what it's asking. That you can't just say yes or no to get the full 3 marks. Now, part 2 is interesting, because when you look at part 2, it's saying each employer receives a $20 pay increase, and they want to know what effect this will have on the standard deviation. So your first question might be, hang on, we haven't even calculated the standard deviation in any of the parts. and now I have to calculate it and then check if this $20 pay increase will change it. Like I have to calculate it again. And if you're thinking that's going to take way too long, you'd be right, particularly since it's worth 1 mark. So I guess this is where you want to think a bit differently. How can I answer this question without doing any calculations? Because I don't actually say justify answer the calculations, and it isn't worth any 1 mark. And it comes back to this. What does the standard deviation actually measure? Remember, it's a measure of spread, how spread apart things are from each other. Now, interestingly, right, when you think about it, if you think about a measure of spread, like let's say you had something from 1 to 10. If you had the numbers from two numbers, like 1 and 10, right? If you increase both of them by 10, that's going to take me from 11 to 20. But the range of those numbers stays the same, right? They're both still 9. So when I think about measures of spread, in reality over here, if each employee raised a $20 pay increase, the standard deviation calculates the spread relative to all the other numbers, relative to the average, right? And if everyone is increased by $20, well, it's like no one's been increased by any amount because the spread is still going to be the same. Yeah. So what effect will this have on the standard deviation? This will have no effect since everybody has been increased, since everybody's wage has been increased by the same amount. Okay, awesome.